Hello students, in this video I am going to solve IIT JEE Main 2026 Shift 1 Organic Chemistry questions. Let's get started with the first question. There is an organic molecule A which upon reduction, so this is catalytic reduction because they are using 2 moles of hydrogen in presence of platinum to form the product decalin. This is called decalin. So that means what? This is telling us that there has to be 2 double bonds. But look at the options. All the molecules have 2 double bonds. So not so helpful. So move on to the next hint they have given here. So the A is treated with KMnO4. Remember KMnO4 is a strong oxidizing agent. So when it is treated, it's going to cleave the bond. And you see that the double bond is cleaved at this particular carbon itself. That means what? Somewhere here there has to be a double bond. So let's analyze this. So if the double bond is here, when it is treated with a strong oxidizing agent KMnO4, the bond will get cleaved here and it is going to form a dicarboxylic acid over here like this. What about this part? This also will undergo oxidation. So you are going to get one more dicarboxylic acid. And that is also given over here. Therefore, what should be the structure of the reactant? The structure of the reactant must be as shown in option 3. So here you are using a retro method because you already know the structures of the products. With the help of the products, you have to find out what is the structure of reactant A. And I consider this as easy to moderate question. The next question is, when a hydrocarbon with the molecular formula C4H8, it is treated with HCl and it is forming compound Q, which is also optically active. And this halo compound, when it is treated with 1 mole of ammonia, so the halogen is being removed by the NH2, therefore it's forming an amine and its formula is R. And this upon diazotization, it is forming an alcohol S. So we are supposed to identify what are these PQRS. The molecular formula for P is C4H8. That means the degree of unsaturation is 1. So it could have a double bond or a ring. But in this case, it cannot be a ring structure. Why so? Because it's going to be reacting with HCl. That means the molecule must have a double bond. So it could be either 1, 3 or 4 and not definitely 2. So you can eliminate this option. See, let's assume if it is 1 butene, right? So when 1 butene is treated with HCl, it will undergo Marconi-Causse addition. So what is it? The electrophile, that is proton, goes to the carbon with more number of hydrogens, right? So the carbon with more number of hydrogen is the terminal carbon. So hydrogen goes over here. And what about the chlorine? It goes to the second carbon. So the product formed is 2-chlorobutane. And this is optically active. But look at option 1. So here 1-chlorobutane is given. Therefore, it's definitely not option 1. Now, it could be either 3 or 4. So that means what? We have to do reaction with 2-butene. So when 2-butene is treated with HCl, see here we don't use Marconi-Causse because this is a symmetrical alkene. So H and Cl will add to 2 carbons here. So like this. And this is 2-chlorobutane and that is also optically active. And let's check for the third. So when it is treated with HCl, it's forming 2-chlorobutane. So this is correct. But look at option 4. Here it's 1-chlorobutane, not possible. So this is kind of anti-Marconi-Causse, so not possible. So it has to be option 3. But let's verify. So when this is treated with, so what is the next reagent given here? Ammonia. It will undergo simple nucleophilic substitution reaction as chlorine is a living group. And you are going to get 2-butanamine. Check for that. Yes, that is there. And then when a primary amine is treated with NaNO2 in presence of HCl, right, at 0 to 5 degrees Celsius. So it's nothing but diazotization. It's going to form diazonium salt since they are not stable. It's going to be hydrolyzed to form an alcohol, and that's nothing but a secondary alcohol, 2-butanol. So this is product S. So this is P, this is Q, and this is R, and this is S. And all of these are correct. Therefore, the right option is option 3. Students, you don't have to verify the steps 3 and 4 here, because in the first and second step itself, you will get to know what is the right option. So you can straight away go with the third option so that you can save some time. The next question is from the basic concepts of organic chemistry from class 11 standard. So you should not miss out any marks from this kind of question as it is direct question. So in Carius method, 0.75 gram of organic compound is converted to 1.2 gram of barium sulphate. We are supposed to find out the percentage of sulfur. The molar mass of sulfur and the molar mass of barium sulphate is already given. This is a direct question. You should remember the formula of calculating percentage of sulfur, that is 32 divided by 233. That is nothing but the molar mass of sulfur and the molar mass of the barium sulphate multiplied by mass of barium sulphate formed. That means what? We are estimating sulfur as barium sulphate, right? So we usually convert it to the precipitate and then we weigh the mass of the barium sulphate and mass of organic compound. Students, remember these two data will be already given in the question. So since it's a percentage, multiply by 100. Then while substituting, be careful. So mass of barium sulphate is given as 1.2 gram and mass of organic compound, we always do it in microscopic. That's why the masses of these compound will be very less. So multiply by 100. So simplify for this. This might take some time. Okay. So be quicker because the values given here have lot of difference. So if you just get the first digit, you just go with that. Okay. So by calculating, you will get the final value as 21.97 percentage. So that is given as option 3. Therefore, the right option is 3. The next question involves series of reactions. Whenever you come across such questions, you should start writing the conversions as you read the question. Say here in this case, an organic compound P, right? It is treated with aqueous ammonia under hot conditions. It's forming product Q. Q on heating with bromine in presence of a base, that is KOH, it is forming R. And the molecular formula of R is already given, that is C6H7 and N. So what are the names of P, Q and R? If you read out the options here, you see there is an acid and then there is an amide and then there is an amine. So that means what? The P has to be an acid. So here you are converting it to an amide. And amide on treating with bromine KOH, this reaction condition should strike your mind that it is Hoffman bromamide degradation. So the product must have one carbon less as compared to your reactant, because in Hoffman bromamide degradation, the name itself suggests degradation. So this will get escaped, right? So what happens to this? It forms an amine. So let's check for the first option. So it's a benzoic acid. So benzoic acid is this. Upon treating with aqueous ammonia under hot condition, it's going to form an amide. Amide is CONH2. So Hoffman bromamide degradation, a named reaction. Most of the times, one of the reactions will be named reaction. So you have to remember that as well. So what is this? It's aniline molecule. So all these are correct, but let's verify it with the molecular formula given here. There are 6 carbons. That's also correct. And then how many hydrogen? 2 here, 5 here. That means 7. And how many nitrogens? There is only 1. So all these things match with what's given in option 1. Therefore, the right option is 1. This is an interesting question which covers alcohols, aldehydes, ketones, and ethers topic. I can classify this from moderate to difficult question. So let's see what is it. An organic compound P with the molecular formula C6H12O3 gives positive iodoform test and negative tolerance test. When P is treated with dilute acid, that means it is hydrolysis, it's going to form product Q, which gives positive for both Tollen and iodoform test. Then what is the structure of the P? You are supposed to find out the reactant structure. Before you jump into writing the different structures of C6H12O3 and checking for the tolerance and iodoform, what I recommend you is remind yourself what exactly are iodoform test and tolerance test. The tolerance test is used to distinguish aldehydes and ketones. When a compound is treated with ammoniacal silver nitrate and it forms a silver mirror, we call it as a positive tolerance test, and it's possible only for aldehydes, right? Here it's given as negative. So negative could be this ketone, or this ketone. Whereas the molecule given in 3 will give positive tolerance test. Therefore, you can eliminate the third option. Now, what is iodoform test? Iodoform test is a specific test whenever a methyl is specifically directly attached to the carbonyl. Here it could be hydrogen, methyl, phenyl, whatever, doesn't matter. Whenever we have such methyl ketone functional group and when it is treated with iodine in NaOH or KOH, it's going to form a yellow precipitate of iodoform. This is a positive test. So it is used to distinguish from methyl ketones to a non-methyl ketone. But look at the options here. This is also methyl ketone. This is also methyl ketone. And so is this fourth option. So not so helpful. Let's look at the next part of the question. When P is treated with dilute acid, so it should undergo hydrolysis. And we know that ketone is not undergoing any hydrolysis. So which part is undergoing hydrolysis? The ethers. So students, remember, whenever we have ethers like this, right? So when they undergo hydrolysis, they are going to form the alcohols, right? Alcohol. So you should know that here also it's going to form an alcohol. But the question is saying that it's giving positive tolerance test. When will it give positive? When it is an aldehyde. But here we are getting an alcohol. No. So there is a hidden meaning here. There is a alcohol which is forming an aldehyde within the molecule. And when is that possible? When it is a geminal diol. And it has to be terminal. So whenever we have geminal diol, what do you mean by geminal diol? When carbon is attached to 2 hydroxyl group, and essentially when it is terminal, what happens? It will undergo dehydration to form the aldehyde. So you look for a molecule where the carbon is attached to 2 ethers because it's undergoing hydrolysis followed by dehydration. Look at this. This upon hydrolysis, you are going to get OH here, which is a vicinal diol, right? So not possible. You can eliminate option 1. Let's look for 2. Here you see this is going to be OH and OH. So that means it will undergo dehydration, or you can call this as formation of the aldehyde. Look at this, how it will undergo dehydration like this. So what product are we going to get? CH3CO, CH2COH. So in the question, when it is undergoing hydrolysis forming Q, it gives positive iodoform test, positive tolerance test. So both are there in the same molecule and it is obtained from the molecule given in option 2. Therefore, the right option is 2. Whereas this one, although it is a geminal diol, it forms geminal diol, it's not terminal. So that means it's going to form ketone and ketones will not give tolerance. Therefore, this is also eliminated. So this is how you have to verify your answer. Thank you for watching this video. In the next video, I am going to solve some more JEE mains questions.